Hi everyone, I'm Micaiah D, and this is my lab report for the charged tapes. So a little background on the lab. The experiment required us to create a net charge on pieces of Scotch tape and measure the excess charge on one piece of tape. The goals of this lab consisted of gaining a better understanding of the electric force, better known as Coulomb's law, between everyday objects and how electric fields affect matter, as well as visualizing the concept of the transfer of charge. So I was able to complete the lab, and I had to make a few minimal changes to my code in order to correctly transfer the data from my experiment to Python. I identified the sign of the charge of the Scotch tape to be positive through different interactions, and the charge that I calculated was within the same magnitude as the textbook example. And I created a virtual representation that I mentioned in VPython by adding functions to calculate charge and using old functions from Lab 0 to help me in finding the magnitude of the forces and create arrows to represent these forces. So here you can see my measurements that I made during this lab, and I use the initial height of tape B and the distance between the tapes to find the height of tape A that caused the repulsion of the tapes to happen. And I use these measurements to help me in my calculations later on. So I observed that the charged tape was attracted to the negatively charged pin, which meant that the tape was positive, and that the net force on tape B is zero since the tape didn't actually float. The center of mass moved slightly, and this floating was caused by the repulsion between the pieces of tape since they had the same charge. Here are my calculations. Notice that the gravitational force and the electric force have the same magnitude, which makes sense since the net force on the tape is zero. And when I was calculating charge, I used the knowledge that the electric force was equal to the gravitational force to be able to manipulate the equation to get charge by itself. And I ignored air resistance and treated the tape as a point particle. So here are the ratios that I was asked to calculate. I found the number of electrons by using the resultant charge that I found and dividing it by the electron charge. And I found the number of atoms on the sticky side of the tape by dividing the tape length by the atom's diameter. And I found the ratio of electrons to atoms by dividing the first answer by the second one. So here's my code, and here's the link to it. So this is the actual size of the code, and notice that the orange arrow is actually the electric force and the green arrow is the gravitational force. This is tape B and this is tape A. And tape A looks to only have one force acting on it, but in reality, the two forces for it overlap. And you can edit the program to be able to see the knowledge behind my code. So some final questions. What if electrons had a positive charge and protons had a negative charge? So the sign in the tape would change, but the interaction should remain the same since everything changes sign of charge. So charged objects should still attract neutral objects. And why is it important to handle the charged tapes as little as possible? Because you have to be mindful of the transfer of charges through contact, and the more that you interact with something, the more that a charge change and the interactions with the tape won't be the same. For example, it will no longer repel another U tape, but they will instead attract each other, which is incorrect for this lab. And so to conclude, this lab helped demonstrate the transfer of charges between everyday objects and visualize Coulomb's law and the reciprocity of forces as we saw with my code, as well as being successful in calculating the excess charges on the tape. Thank you so much for watching, and I will return with the next lab report.